Hello friends, in this one, let's take a look and go down a rabbit hole in complex analysis. So I have f of z is defined as ln of z, and what I really want to do is just study what ln of z will do in the context of complex analysis to this number that's defined by r times e to the I pi over 4. That basically represents a ray that leaves the origin at pi over 4 radians and just goes forever. So notice that the angle for this complex number is fixed at pi over 4, but the r is not. It's allowed to vary. And what we want to do is study what happens to the image of this under this function ln of z. So what I'm going to do is I'm going to stick as follows. I'm going to write f of r times e to the I pi over 4. I'm going to stick that into the ln function for complex numbers. So it's going to become ln of r times e to the I pi over 4. Then after that, I'm going to apply a basic log rule that says because you have ln and you have a product inside there because it's r times e, you can just write this as ln of r plus the ln of e raised to the I pi over 4. Again, a basic power rule for logarithms is that you can just take the quantity in the top, I times pi over 4, and you can just bring it down. So if you do that here, it's going to come out as ln of r plus I times pi over 4. And notice back here above my head, remember the ln and the e functions are inverses, they cancel off, they go away. So the result is that you end up with ln of r plus I times pi over 4. That's the image under the natural log function here of this complex quantity r times e to the I pi over 4. Now take a look at something here. Look at this result. Well, first of all, the ln of r plays the role of the real part of the output. And the I times pi over 4, that's a fixed quantity. The pi over 4 is like the imaginary part of it. But notice that the real part is a function. So what does that actually tell us? How do we understand things a bit better? So let's take a look. Just treat ln of r as a regular old function. So what I'm going to do is take some limits. Take a look. So the limit of ln of r as r approaches positive infinity is infinity. The limit of ln of r as r approaches 0 from the right is negative infinity. Why am I looking at the limits? Because remember that ln of r is the real part of our complex number, the output complex number. So I need to understand what's happening. Take a look at this at step 6 here. So here on the vertical axis, I'm graphing ln of r, and remember that ln of r is the real part of the ln of r times e to the I pi over 4. That's all it is. Basically, this kind of really condensed notation, it just represents this, the ln of r, that's all. If you look at this, take a look. So when r shoots off towards positive infinity, you see that ln of r, which remember is also the real part of that number that is output, that also shoots off towards positive infinity that way. Then this graph, when r approaches 0 from the right this way, then you see that ln of r goes down towards negative infinity. Remember that in this axis, the vertical axis represents the real part of this quantity above my head, ln of r in other words. So lastly, with that connection hopefully established clearly, what we can do is produce the final image right here, ln of r plus I times pi over 4. It looks like this. So this point above my head, that's I times pi over 4. And that entire line that looks like that, that's traced above my head, that's ln of r plus I times pi over 4. Here, the horizontal axis is the real axis. The vertical is the imaginary as usual. And again, it looks like this. It looks like a line. The reason is that I times pi over 4 is fixed. So it's passing through that vertical axis at pi over 4. But the real part is ln of r. So let's make sure we understand the connection. This part right here, when r goes towards infinity, ln of r also goes towards infinity. That tells you that this line above my head goes forever this way, see? For the second part, where it says r approaches 0 from the right, and ln of r goes towards negative infinity, that shows up in picture 7 by going this way. See, it's going forever to the left. And remember that here there are points, right? And at each point, for example, on that line above me, it's equal to I pi over 4 and a particular value of ln of 4, or rather ln of r. Where are these coming from? Remember, these are just the real parts, correct? Right here. So this part of the axis, that corresponds pretty much to like that part going towards negative infinity. This part of the axis above my head, that corresponds to this part right here, where you go off towards positive infinity. All right, and remember that this is all representative of the image of r times e to the I pi over 4. I'm going to leave a small exercise for you. What I want you to do, to the best of your ability, is sketch r times e to the I pi over 4. Remember, this has a fixed angle, but r, which is the length, is not fixed. So I'm just going to give you a verbal description. You may want to jot this down on your paper and then try to reproduce it in the picture. It basically is like a ray at an angle of pi over 4 that shoots out forever. So this ln function takes that, it passes it through itself, so to speak, right? It kind of, you feed it into the ln function, it produces an image, and the image of that ray is this line above my head. That's the mystery. That's about it, though. Thank you so much for watching. Please leave a like and subscribe. I hope this has shown you something insightful. I'll see you in another video.